హలో స్టూడెంట్స్, వెల్కమ్ టు గోవిద్య. సో మనకి తెలంగాణ జెన్కో ట్రాన్స్కో డిస్కమ్స్ అలానే ఆంధ్రప్రదేశ్ సంబంధించిన జెన్కో ట్రాన్స్కో డిస్కమ్స్కి సంబంధించి సో ఏవైతే ప్రీవియస్ ఇయర్ క్వశ్చన్స్ ఉన్నాయో సో అలానే కొన్ని ఇంపార్టెంట్ క్వశ్చన్స్ ఉన్నాయి. ఓకే, సో వీటిని మనం ఇప్పుడు డిస్కస్ చేయబోతున్నాము. ఓకే, సో ఈ సెషన్లో నెట్వర్క్స్ సంబంధించిన క్వశ్చన్స్, సో మీరు ఈసీఈ వాళ్ళైనా ఎలక్ట్రికల్ వాళ్ళైనా ఈ సెషన్ అటెండ్ అవ్వచ్చు. సో దీనికి సంబంధించి సో డిఫరెంట్ మోడల్ ఆఫ్ క్వశ్చన్స్ అనేవి నేను ఎక్స్ప్లెయిన్ చేస్తాను. ఓకే, సో ఐ విల్ డిస్కస్ డిఫరెంట్ మోడల్ క్వశ్చన్స్ so and some concepts related to so this networks. Okay, so whatever concepts are coming here continuously and some of the concepts we need to concentrate definitely. Okay, so those kind of models I will definitely cover in all these sessions. Okay, so not only one session, so this is the first session and similar like this. Okay, so we will conduct so many sessions, so mostly every day we will be discussing some questions on this. Okay, so it may be networks, control systems or some other subjects. Okay, so like one by one we will discuss about all the subjects. Okay, so let's see the questions first. Okay, so these sessions completely these questions based only. Okay, these sessions are like only questions we are discussing, so with some concepts related to this. Okay, so and in between if you get any doubts, so you can just message here in chat box, I can reply for that. Okay, so the first question, which of the following statements are wrong with respect to three-phase systems? So three-phase systems. Okay, so RYB in clockwise phase sequence. Okay, so clockwise phase sequence they have given. So in a balanced delta system, line currents are 30 degree behind the respective phase currents. Okay, so they have given about delta system. Okay, so in a balanced star system, line currents are 30 degree behind the respective phase currents. Okay, so next, in a balanced star system, line voltages are 30 degree ahead of the respective phase voltages. Okay, so next, in a balanced delta system, line voltages are 30 degree behind the respective phase voltages. Okay, so they have given about star and delta connection, voltage and current relation only. Okay, so line currents and phase currents, line voltages, phase voltages. Okay, so here basic thing is, so in a star connection, okay, so in a star connection, phase voltage will be equals to, okay, so phase voltage will be equals to 1 by root 3 times of line voltage. Okay, so that we can understand. Otherwise based on the currents also we can give. Okay, so like phase current. Okay, so phase current equals to, okay, so line current. Okay, so phase current equals to line current. Similarly in delta connection, okay, in delta connection voltages will be same. Okay, so based on this concept we can directly answer this. So they are asking wrong. Okay, so which of the students are asking? Okay, so answering already. So which of the option is correct? Okay, so option B, everyone, option B. Okay, so let's see, 2 and 4 only wrong. Okay, so they are saying 2 and 4 only wrong. Okay, second one is see, so in a balanced star system, line currents are 30 degree behind the respective phase currents. Okay, so in a star connection they are asking, they are giving here 30 degree behind, but both are same only. Okay, in star connection I phase equals to I line. Okay, so in star connection, okay, so that's why this statement is wrong. Okay, so similarly, okay, so similarly fourth one. Okay, so in a balanced delta system, line voltages are 30 degree behind the respective phase voltages. Okay, so 30 degree behind the respective phase voltages. Okay, so already we know. Okay, so in delta connection, okay, so phase voltage will be equals to line voltage. Okay, so from this directly we can answer. So answer for this question is option B. Okay, so I will give you 1 minute. Okay, so within 1 minute we have to solve this question, so as early as possible. Okay, so whenever you see the question, so immediately you try to answer this question. Okay, so it will be useful for you. Okay, so next question. Okay, so the H parameters of the following circuit shown in the figure. Okay, so H parameters they are asking. So they have given one network. So input voltage, input current, output current. Okay, so like that they have mentioned. Okay, so all four. So immediately, okay, so whenever this kind of question is there, okay, so whenever two port network question is there, so what you have to do? So immediately you need to write the equations. Okay, so you try to solve within 1 minute. Okay, so I will be observing the answers. So if possible, you give the answer for this one. Okay, so whenever a network is given for us, H parameter model they are asking. Okay, so our H parameters they are asking. So H parameter equations are, okay, so for remembering, okay, so you can remember like this: V1, I1, so V2 and I2. Okay, so like this if you write, so it will be H11, H12. Okay, so it will be H21 I1 plus H22 V2. Okay, so we need this, and we need H11 and H21. For example, if you need these two, so here V2 we have to make 0. So V2 we have to make 0 means second port you will be short circuiting. Okay, so I will remove these two. So I will make V2 equals to 0. Then this part will be becoming 0. So then in all these, okay, so I can connect something like 1, so V1 by I1, so H21 is I2 by I1. Okay, so for this I am connecting. Okay, so I1 one current source I am connecting directly, which is 1 ampere. Okay, so if 1 ampere I am connecting directly, I1 we are getting, right? Okay, so what will be the V1? V1 is the voltage across this. Okay, so if 1 ampere is going like this, here second port, okay, what we have in second port? Second port we have made equals to 0. That means short circuit we have made. Understanding? Okay, second port, so like V2 we have already made it as 0. Okay, that's why it is short circuit. Okay, so from this one, okay, so you just observe, so directly H11 equals to V1 by I1. What is the voltage V1? See, V1 is directly short circuited. See, V1 is voltage between these two. There are no other elements. Okay, so that's why directly V1 equals to 0. So H11 you will get equals to 0. Okay, similarly I2, what is I2 value? You see 1 ampere you have connected, so I1 current will be 1 ampere only. So I2 current is, see, here no current will flow because of the short circuit, no current will flow here. Okay, so it will be, so minus 1 ampere. Okay, so like this we can give. Okay, so I2 value is nothing but minus 1. So from this one H21 equals to minus 1 by 1, which is minus 1. Okay, so H21 equals to minus 1 you got. Okay, so where is the option? So you can check. Okay, so two options are satisfying here or one option only. Okay, so H11 equals to 0. Okay, everywhere it is 0 only. H21 equals to, okay, so H21 is minus 1. Okay, so two options are getting satisfied. So we'll try the second method, second calculation also. Okay, so whenever this circuit is there, again, okay, so this will be I2, so this will be I1. Okay, so V1, V2. Okay, so now the complete equations will be like this. Okay, so V1 equals to H11 I1 plus, so H12 V2. Okay, so plus H22 V2. Okay, so now I will remove this part. Okay, so I want to make this part equals to 0. That means I1 value we have to make equals to 0. Okay, so I1 value we have to make equals to 0, H22, and this will be H11. Okay, so it's not minus. Okay, so H12 and this is H22. Okay, these two values you can find out, but I1 we have to make 0, so this will be open circuit, and here see V2 is there common in both the calculations. Okay, so that's why I will connect some 1 volt. Okay, so 1 volt I am connecting here. So now what do you need? V1. Okay, so V1, so if you are connecting 1 volt, here also 1 volt only you will get. Okay, so V1 divided by V2 is H12. H12 value is 1. Okay, so H12 you will get as 1. Okay, so similarly H22 is I2 divided by V2. Okay, so what is the value of I2? If it is 1 ohm, okay, already the entire current is going through this resistance only, so that means 1 divided by 1, so 1 ampere will be going here, so that I2 is also equals to 1. Okay, so that means, so directly you will be getting 1. Okay, so I2 equals to 1, and similarly V2 is also 1, H22 equals to 1 you will get. Okay, so option for this is 0, 1, okay, -1, 1. Okay, option D is the correct one. Okay, so only for solving here it is taking more time, but generally it will give very fast only. But why only this method? Okay, so we can solve in different method, right? So this is conventional method, like it may take for you. Okay, so circuit whatever they have given, so this circuit parameters. Okay, so how to get H parameters? Let's write the equation. So V1 equals to H11 I1 plus H12, okay, so V2. Okay, so you can while remembering, okay, you can do like this: V1 I1 and V2 I2. Okay, so H21 I1 plus H22 V2. Okay, see, whenever equations we are comparing, okay, so we can get the answers very fast. Okay, so that's why, so equation comparison method is very good. Okay, so let's see this. Okay, so no need to remember any formulas. Okay, so no need to remember any formulas, so directly we can do this. Okay, so just like, so just observe this one. Okay, so how you can get. Okay, so we need equation in terms of V1 equals to I2 equals to, already V1 equals to is there. Okay, see, any equation, so these are available equations, we need this kind of equations, right? Okay, these are available equations, these are required equations. You want in terms of like this, you can modify these equations like this. Just see the terms. Okay, so in this equation V1 I1 V2, okay, anything is there like this. Okay, V1 I1, okay, V2 is not there, V1, okay, V1 only not there. That means this equation is not matching with any of these two equations. Okay, leave it. Okay, so here I2 I1 V2, okay, I2 I1 V2. Okay, so where it is matching, see, I2, okay, I2 I1 V2. Okay, so that means these two equations, you can modify this equation to make this kind of equation. That means you need to write it as I2 equals to first I1 term. Okay, so minus I1 plus V2. Okay, so minus I1, you can send this other side. Okay, so that means directly you are getting, okay, I2 equals to minus I1 plus V2 you are getting. Okay, so now if this one, okay, so this one, if you are substituting in this, okay, so directly you can get another equation. Okay, so that means in first equation you have to solve, you just check once, so not in this one, you have to substitute in the available equation. Okay, so I will substitute I2 equals to minus I1 plus V2. Okay, so you will substitute here, so just observe here. Okay, so I will substitute it here. Okay, so just like, okay, so this equation I am substituting in the first one, so I will get V1 equals to I1, directly I am writing plus, in place of I2 I am writing minus I1 plus V2, minus I1 plus V2. Okay, so here I1 will cancel, and similarly only V2 only available. Okay, so 0 I1 plus 1 V2. Okay, so this is the another equation. Okay, so these are the two equations we got. Okay, so in H parameter model, you see, this is the first equation and this is the second equation. Okay, from this one, H11 equals to 0, H12 equals to 1, H21 equals to minus 1, H22 equals to, so here coefficient of this is 1. Okay, you can solve like this also. Okay, so this is more comfortable method. Okay, so here question is simple only. Okay, so that's why you are getting it as comfortable. Okay, but when the question become more tough also, okay, so this method will give more faster solution. Okay, so compared to any other solution. Okay, so here no other models are giving this much advantage. Okay, so that's why, so you try this method. Okay, so whenever comparison, okay, so you are having, these are available equations. Okay, so available equations, so these are required equations. Okay, so required equations. Okay, so from the available equations you need to get the required equations. Okay, so how you can get, So by just modifying these, okay, so by only modifying, so you can get this, okay. So there is no other thing, okay. So you have to just modify these, okay. So that's how you can do, okay. So let's do the next question. So a network has n nodes and I independent loops. The number of branches in the network is, okay. A network has n nodes and I independent loops, okay. So independent loop means number of meshes. Independent loops are nothing but number of meshes, okay. So number of mesh equals to I they have given, okay. So n nodes, okay. So number of nodes, so they have mentioned number of nodes as n, okay. So what they are asking, the number of branches in the network, okay. So you know already, okay, number of meshes to I plus n minus 1, okay. I plus n minus 1, okay. So I plus n minus 1, okay. So this will be the correct answer for us, okay. So the next question, this is simple question only, okay. So every time, so in most of the examinations, okay, so like Genco Transco examinations, okay, so most of the times this model of questions definitely they will give, especially only from the formula, otherwise maybe from small calculation, okay. So they will definitely give this model of question, okay. So next question, read the following statements. In a three-phase star connection, VL equals to root 3 times of V phase. In three-phase star connection, VL equals to V phase. In a three-phase star connection, line voltages are 120 degree apart. Choose the correct answer, okay. We need to select the correct answer for this, okay. So just check, okay, what is the correct answer for this, okay. So this is about star connection they have given, okay. So first one, in three-phase star connection, VL equals to root 3 times of V phase. Root 3 times of V phase, okay. So that is correct only, okay. So just like a star connection we are taking, okay. So star connection, if this will be the neutral, okay. So R and this is Y and this is B, okay. So between these two, whatever voltage is there, this is nothing but phase voltage, okay. So between these two, whatever voltage is there, this is nothing but phase voltage. Between these two, voltage is phase voltage, but 120 degree apart it will be, okay, system, okay. So they did not mention anything, but so balanced system only we can consider, okay. So V phase at an angle of 0 degree, V phase at an angle of minus 120 degree, V phase at an angle of minus 240 degree, okay. So three voltages they have given like this, or we have taken this, okay. And they are asking about, so line voltages and phase voltages relation, okay. So you see, line voltage means between R and Y what will be the voltage, between the Y and B what is the voltage, between the R and B what is the voltage, okay. If you take this, you will get root 3 times of V phase magnitude, root 3 times of V phase magnitude, and third one is also root 3 times of, okay, from here to here also it will be root 3 times of V phase magnitude. So but these three also aparted by 120 degree only, okay. So I will give you, so in three phase star connection, VL equals to root 3 times of V phase. This is correct one, okay. So first one is correct only, okay. So next, second one, okay. So in three phase star connection, VL equals to V phase. This is wrong. B should not be there, okay. So that means third one, in three phase star connection 120 degree apart. Okay, so this we need to prove first, okay. So let's take the line voltages first, okay. So I am taking VR, okay. So R phase voltage, which is line voltage, phase voltage, okay. So phase voltages, okay. So phase voltages, so I am giving VR, okay. So VY and VB and RYB phase sequence I am taking, okay. So this is VR after the 120 degree, so you'll be having VY. After 120 degree you will be having VB, okay. So now line voltages, okay. What are the line voltages? So you can take line voltages as, okay, so VRY, okay. So let's take one, okay. First VRY equals to VR minus VY, okay. So you can write down it as VR plus minus VY, because vectors can be added, okay. Vector addition only available for us, that's why we are doing vector addition, okay. So see, everyone is answering B, okay. So that is okay, so correct only, okay. So I want to give you some more points, that's why I am giving this, okay. So VR plus minus VY, okay. So VY is here, where is minus VY? So minus VY will be here, okay. So same magnitude it will be, it is minus VY. So VR and minus VY, if you add these two, okay, how you can do addition? So however is this vector, we need to add here, okay, extend this. However is this vector, so we need to, so now angle we need, okay, so angle we need. So actually angle difference between these two is 120 degree. So angle difference between these two is 120 degree. Angle difference between these two is also 120 degree. But whenever you have drawn minus Vy, so this angle will be, entire angle will be 60 degree. Okay, so now only this angle, both are having same magnitude because it is a balanced system. Okay, so you can consider this directly as 30 degree. Okay, so that means this will be a phase voltage, this will be line voltage. Okay, so you can consider phase voltage. Okay, so phase voltage, okay, so in balanced star connection, okay, phase voltage lags line voltage by 30 degree. Okay, so here VR will be lagging, okay, so compared to VRY, and magnitude you can check. Okay, so this will be √3 times of this magnitude. Okay, so we cannot prove here now immediately, so later in some other question we will do this one. Okay, so option B is correct one only. Okay, so but what is the next one? Okay, so what is the next voltage we need? Okay, so instead of VRY, so now we will take VYB. Okay, VYB is Vy plus minus VB we can take. Okay, so VB is here. Where is minus VB? So minus VB we can consider here. Now to add, okay, so VR and minus VB, so both you need to add. Okay, so where you can add? So extend this similar like this. Okay, in parallel to this. Okay, extend this. Okay, see from here in parallel to this. So now you need to give it here. Okay, so wherever these two are touching, it will be VYB. Okay, so now what is this angle actually? You just observe. Okay, so total from here to here it will be 120 degree. Okay, from here to here it is 120 degree. Okay, whenever you have drawn minus VB, then this will be 60 degree. So remaining will be 60 degree, and this will be 30 degree. Okay, that means this is at minus 120, so this will be minus 90. Okay, you can give like this. So VRY is at so some magnitude which is √3 times of V phase at an angle of 30 degree. Okay, so now VYB, okay, so VYB, okay, so YB equals to √3 times of V phase at an angle of, see you can get it as minus 90. Okay, so from here to here minus 120, so from here to here it is minus 90 only. Okay, so you can give as minus 90 otherwise. Okay, so directly you can get, so first voltage is at an angle of 30, second voltage 30 minus 120. Okay, third one is 30 minus 240. Okay, so you can give VBR, okay, so equals to √3 times of V phase at an angle of minus, okay, so total minus 240 actually, but 30 degree in lead, that's why minus 210. Okay, but angle difference between these two is 120 degree. Angle difference between these two is 120 degree. Angle difference between these two is also 120 degree. Okay, so like that. So even though line voltages, okay, so phase voltages we have taken as 120 degree apart. Okay, so just see, so line voltages we have taken we have given as 120 degree only. Okay, so whenever you have taken this phase voltages, okay, if the system is balanced, okay, you are getting balanced system and angle difference is 120 degree, whenever you convert into phases also, okay, so same it will be, but you have to observe one thing. Okay, so here line voltages are 30 degree leading. Okay, so leading means it will come first. Okay, so when you put your hand, okay, so first this vector is coming, next this vector is coming. Okay, all the vectors will rotate in anti-clockwise direction. Okay, so RYB phase sequence I have given. See, first R, after that Y, after that B. Okay, so first R will go, after that Y will go, after that B will be going. Okay, so this is the sequence we are getting. Okay, so anyhow from this we can understand, okay, so the relation between phase voltages and line voltages, okay, so which is lagging and which is leading we can understand. And similarly, okay, so we can get the magnitudes also. Okay, so this is about the star connection we have given. Okay, similarly for delta connection we can do the similar kind of analysis based on the currents. Okay, so line currents and phase currents we can get. Okay, so anyhow based on the load the current is lagging or leading, based on that we can understand. Okay, so how much is the, so angle difference between voltage and current, that represents the power factor. Okay, so in this question they did not ask about power factor, so they have asked about only three conditions. Okay, so you see, so first one is in three phase star connection VL equals to root 3 times of V phase. That's fine, no problem. Okay, in three phase star connection VL equals to V phase, this is correct. Three phase star connection, that's why this is wrong. In three phase star connection line voltages are 120 degree apart, that's correct only. Okay, so A and C are correct, so they are asking about. Okay, so choose the correct answer. Okay, see, nowadays most of the question papers are coming like this. Okay, so they are asking either choose the correct statements or choose the wrong statements. Okay, so you have done everything correct, but if you select only C, okay, so only B, so that option is also there, that is wrong one. Okay, so you have to observe and answer. Okay, so next question, in two port network where inverse hybrid parameters are used. Okay, so inverse hybrid parameters, so when we have to use, that's what they are asking. Okay, so inverse means dependence has to be converted as independence has to be converted as dependence. Okay, so but remember one thing. Okay, so whenever they are asking about two port network, immediately you need to give the equations. Okay, so you will get more clarity. Okay, so just for example, okay, see, I want to give more clarity about two port network, so that's why I'm giving this solution here. Okay, so Z parameters, for example. Okay, so Z parameters, see, for Z parameters generally we can give. Okay, so V1 equals to V2 equals to, because voltages equals to, you will write down. Okay, so this is Z11 I1 plus, so Z12 I2. Okay, so this is Z21 I1 plus Z22 I2. Okay, so here what are independents and what are dependents? See, equation this side, whatever currents and voltages are there, this will be independents. Okay, so these are independents. Here these are the dependents, voltages are depending upon current values. Okay, so that's what it is. Here this side it is dependents. Okay, so dependents, and these are independents. Okay, so independents. Okay, so now what they are asking, they are asking about H parameters. Okay, so our inverse H parameters they are asking. Okay, so now H parameters generally, okay, most of the examinations they will give the H parameters only. Okay, they won't ask about other parameters, they will definitely include the H parameters. That's why you remember like this. Okay, so I'm giving you some directly remember for a shortcut. Okay, so you just write down V1 I1 V2 I2. Okay, so you write down like this. So these are the H parameters. Okay, so H parameters, so here I1 will follow like this, V2 will follow like this. Okay, so H11 H12 H21 H22. Okay, so only for remembering. Okay, if you can remember the equation directly, so there is no problem at all. Okay, so if you can't remember, you remember like this. Okay, V1 I1 V2 I2. Okay, so in this order you have to remember. Okay, so anyhow here they are asking about inverse H parameters. See, here these are the dependents, these are the independents. Okay, so now if inverse, okay, so inverse H parameters. Okay, so inverse, okay, so inverse H parameters. Okay, so inverse H parameters, so for inverse H parameters what will happen, what are the dependents, what are the independents they are asking. Okay, see, dependents will become independents. Okay, so dependents will become independents. So what are the dependents actually? So dependents will be I1 V2. Okay, so independents, okay, so independents will be V1 I2. Okay, so based on this you need to answer this question. Okay, so what are the dependents and what are the independents? Okay, so try to answer this. Okay, so what you will get, so dependents. Okay, so dependents are I1 V2. Okay, so dependents are I1 V2. Okay, so dependents are, so dependent variables are, okay, so dependent variables are I1 V2. Let's check this one. Okay, so V1 and I2 are independent. Okay, so V1 and I2 are independent, V1 and I2 are independent. Okay, so then V2 and I1 are dependent. Okay, so this will be correct answer. Okay, na, so let's we have to check like this. Understanding, right? Okay, so very important model, H parameters. Okay, in two port network, so definitely, okay, so if you believe or does not believe, every time two port network H parameters one question is coming. Okay, so that's why I have given this question, and you need to remember the equations. Okay, so any case, okay, you have to remember the H parameter equations. If not, you just follow this method. Okay, so V1 I1 V2 I2, in this model you just remember. So most of the other equations you will remember, like Z parameters we know voltages equals to, okay, Y parameters currents equals to, we can get. Okay, similarly H parameters means, okay, input voltage, output current. Okay, so like that if you remember, no problem. Okay, so then you can get, otherwise you try this method. And ABCD parameters, input side equals to, okay, so sending side will be equals to, so you will get the in combination of receiving side. Okay, that means V1 equals to I1 equals to two equations. Okay, so V1 equals to A V2 plus B I2. Okay, so like that you will write down the equations. So anyhow you can solve that. Okay, so next question, the node based matrix equation of the circuit shown below is, okay, so the node based matrix equation, so they are asking about matrix equation. Okay, so that means just we need to write down the equations only. Okay, nodal equations you have to write down. Okay, so let's give nodal equation here, but they have given in terms of mho. Okay, in terms of mho they have given, so that means these are not resistances, these are conductances. Okay, so anyhow let's give one thing. Okay, so V1 minus 0. Okay, so let's take this as the reference. Okay, so 0, so V1, okay, so minus 0 divided by resistance we have to use. Okay, resistance is here 1 by 3, you will get the resistance, otherwise you can multiply with 3. Understanding? Okay, so divided by 1 by 3, otherwise you can add 3 here. Okay, so plus V1 minus V2 divided by 1 by 2 you have to use, so that's why multiply by 2. Okay, so and here 4 amperes is incoming current we can consider as minus. Okay, so minus 4, so equals to 0. Okay, so this will be one equation. Okay, so you can write down 3V1 plus 2V1 minus 2V2. Okay, so next minus 4 equals to 0, otherwise you can write down equals to 4. Okay, so total 5V1 minus 2V2 equals to 4. Okay, so this is the first equation. Okay, so 5V1 minus 2V2 equals to 4. Okay, 5V1 minus 2V2 equals to 4. 5V1 minus V, everywhere same only, right? Okay, so what we can do, second equation we have to solve. Okay, so that's what. So next V2, so from here it will be ground, V2 minus 0 divided by 1 by 3, so I'm writing into 3. Okay, so V2 minus V1 plus V2 minus V1, so divided by 1 by 2 you have to write, so I'm writing into 2. Okay, so next this is outgoing current, for this node this is outgoing current only, so I'm writing plus 1.6. Okay, so it will be equals to 0. Why equals to 0? We are writing KCL equation. Okay, so that's why algebraic sum of the currents at a node or junction equals to 0. Okay, so you can simplify this one. So how many V2 terms? 3V2 and 2V2, total 5V2. Okay, so next V1 term. Okay, so minus 2V1. Okay, so equals to, this will go to other side, it will be minus 1.6. Okay, so this will be second equation. Okay, so you see what is the answer here? Minus 2V1 plus 5V2 equals to, so minus 1.6. Okay, so option 1 is the correct answer for this. Okay, so option A is the correct one. Okay, so just confirm once. Okay, so minus 2V1 plus 5V2 equals to minus 1.6. Satisfied? Okay, 5V1 minus 2V2 equals to 4. Okay, so option 1 is the correct one. See, for understanding, okay, so I have to explain, right? That's why little bit slow, one by one I'm explaining. Okay, so generally we can solve within like 20 seconds only this question. Okay, nothing to worry. Okay, so whenever you see the question, you have to solve immediately. Okay, one method. Okay, any one method you have to fix. To get that method in your mind, you need to practice more. Okay, so that's why. So answer for this question is C, no pen paper. Okay, so yeah, no pen paper. Okay, so correct only. Okay, so you can do this question without even seeing. Okay, so and you can do so many other examples also are there. Okay, to solve this one. See, voltage across this is V1, voltage across this one is V2, okay, so and you can check current also, okay, so based on that V1 V2 relation only we can directly give this, okay. So anyhow, so these two equations also if you add, so then also some shortcuts also will be there, but originally this method, see there is no much confusion, okay, so only one method we have to follow, that's it, okay. Whenever you solve it for more number of times, like similar questions if you try to solve, then you no need of any pen and paper, okay, so directly you can able to solve this, okay. So the next question, a three-phase star connected supply of phase voltage of 100 volt 50 hertz is supplying a three-phase star connected resistive load of 5 ohm per phase. Find the total active power supplied to the load, okay. So what they have given, three-phase star connected supply they have given and having a phase voltage of 100 volt 50 hertz, okay. So whenever AC supply is given like this, okay, so AC supply is given like this, so whatever value they have given, it will be RMS value directly, okay. So you have to remember this, so whatever value they have mentioned for AC supply, it will be directly RMS value, okay. And they have mentioned here supplying a three-phase star connected resistive load is there, and this resistive load we are supplying using a one balanced, okay. So a three-phase star connected supply of phase voltage 100 volts, okay. So that means mostly here we have to consider it as balanced only, okay. So find the total active power, okay. So that means, so they have given this as the phase voltage or line voltage across this, so directly they have given it as phase voltage only, okay. So voltage across this resistor is 100 volts which is RMS, and resistance value is 5 ohms. Power in the first phase, okay, so power in the first phase we can calculate as, so V RMS square divided by R, okay. So V RMS means 100 square divided by 5, okay. So 100 square is nothing but 10,000, 10,000 divided by 5 is 2000, okay. So 2000 watts will be active power in the first phase, and remaining phases also you are having same resistances only, 5 ohms each is there, okay. So that means directly answer is, okay, so directly what will be the answer, so answer will be A, okay. So I thought this is the answer for the last question, okay. So no pen and paper also required, okay, don't worry about that, okay. So you can use the pen, don't worry, okay, sometimes you will do the mistakes, okay. That's why even though if you know, so just to keep the pen rough, you just to do like that, okay. So it may take only 5 seconds 10 seconds only, definitely use pen and paper, okay. So without that sometimes you may do the mistake, okay. So the next question, a two-port network is defined by the following pair of equations. I1 equals to 2V1 plus V2, okay. So I2 equals to V1 plus V2. Its impedance parameters are, okay, what you have to do, so whenever Y parameters they have given, okay, so Z parameters we can get as inverse, if you take then you will get the Z parameters, that's it, okay. So directly matrix I am taking, okay, so and Z equals to, so directly I am giving 2 1 1 1, okay, inverse, that's it, okay. So inverse means into 2 1 1 into 1 1 only, okay. So 2 minus 1 is 1, okay. So determinant will be 1 by 1 into D minus B minus C A, okay. So D is 1 minus B minus C E A, okay. So answer will be 1 minus 1 minus 1 2, okay. So option C is the correct one, okay. So answer C is the correct one, okay. So that's it, right, okay. So just answer everyone whether you got the same answer or not. So just by observing option C, okay, so that's okay, no problem, okay. Okay, see, I'm not giving the best method to solve, okay. So we have to recollect each and everything, that's why I'm giving like this, okay. So no need, okay. So if you can observe and answer, then it's fine, no problem at all, okay. Option C is the correct answer, okay. So let's see the next question. The value of H22 for the network shown below is, okay, H22, okay, hybrid parameter H22 they have given, so it will be in the second equation, you know, okay. So H22 means, see, whenever H parameter they are asking something, immediately what you have to do, equation you have to do. Okay, so if you write the equation, then immediately we'll get the solution. Okay, so second H22 will be in the second equation, so I'm writing V1 I1 V2 I2. Okay, so I2 equals to, so here I1 and here V2. Okay, so V2. Okay, so H22 and this will be H21. Okay, you want H22, that's why I1 we have to make it equals to 0. Okay, so we have to make it equals to 0. So H22 you will get as, okay, H22 equals to I2 divided by V2. Okay, so I2 divided by V2. So first, before that, we have to make I1 divided by V2. Okay, so let's connect some voltage here. Okay, so it may take, let's take 10 volt. Okay, but no current will flow inside. Okay, so I2 will be equals to 0. Okay, so whatever you connect here, I2 will be equals to 0. So directly 0 divided by 10. Okay, so 0 divided by 10 is 0 only. Okay, so directly answer is option B. Okay, so method we have to follow like this. Okay, so correct only, right? Okay, so if any doubt is there, you can ask me. Okay, okay, so let's solve the next question. Okay, so which of the following two port parameter is dimensionally different from the other three? Okay, so dimensionally different from the other three. Okay, so let's see Z parameters. Okay, so Z parameters Z11, Z12, Z21, Z22, everything will have units of ohms only. Okay, so Y parameters, so everything will have the unit of Y11, Y12, Y21, Y22, everything will have more. This everyone knows. Okay, so then remaining we have to solve. Okay, so remaining A, B, C, D. Okay, so what are these units? Okay, so A will have, okay, so generally from the equations you have to get. Okay, so A, from A units are, okay, so directly we can give V1 equals to A V2 plus B I2. Okay, we can give like this. That means A does not have any units. Okay, so no units. Okay, so no units. So B will have the ohms. Okay, so C will have the unit of mho. Okay, so D have the units, no units. Okay, so no units. Understanding? Okay, so D will have no units. Okay, so now from this one, Z11 will have this we know. Okay, so under B will have ohms. Okay, so remaining two only we have our answers. Okay, so now H11 and H22. Okay, so these two we need. Okay, H parameter equations directly we have already solved before. Okay, so H parameter equations, so this will be I2, so you will get V1 equals to H11 I1 plus, so H12 V2. Okay, so that means here H11 units are V1 by I1. Okay, so V1 by I1 is H11 unit is ohm. Okay, so H11 in terms of ohms. Okay, so H12 no units. Okay, so no units. Okay, so H21 no units. Okay, so H22 will have units of mho. You can check here. Okay, so H22 will have, so whenever this is not there, okay, so current divided by voltage, you will get the unit of mho. Okay, so anyhow, answer for this question is, which of the following two port parameters is dimensionally different from the other three? Okay, so H11 also will have unit of ohm. Okay, H22 will have mho. Okay, so option for this is option D. Okay, D have to be the answer. Okay, so correct only. Okay, so let's see the next question. Okay, say linear two port network. So when 10 volt is applied to port 1, a current of 4 amperes flows through port 2 when it is short circuited. When 5 volt is applied to port 1, a current of 1.25 amperes flows through a 1 ohm resistance connected across port 2. When 3 volt is applied to port, the current through a 2 ohm resistance connected across. Okay, so here this model of questions. Okay, so generally they will give, so most of the times in examinations. Okay, So I will give you one method, you try to solve like this, okay? So you will definitely get. So here actually three conditions are there, okay? So what is the first condition? A linear two-port network, they have mentioned linear it is, okay? So when 10 volt is applied to port 1, a current of 4 ampere flows through port 2, okay? So when it is short circuited, okay? So a two-port network is there, okay? A two-port network is there. Input side, if you have connected, how much voltage? 10 volt is connected, okay? 10 volt is connected. So output is short circuited and here current is 4 amperes. So this is the first condition they have mentioned, okay? So when 5 volt is applied at port 1, a current of 1.25 ampere flows through 1 ohm resistance connected across port 2, okay? So now what they have given? So 5 volt they have connected here to the same two port network, okay? So and secondary side what they have connected? So they have connected, what is that? So resistance of 2 ohms, okay? So resistance of 1 ohm they have connected, okay? So 1 ohm they have connected and they got the current as 1.25 amperes, okay? So these are the available conditions and now they are asking when 3, okay? So when 3 volt is connected to the same two port network, okay? So and output side what we have connected? A current through 2 ohms resistance connected across 2 ohms is, okay? So at the second port, whenever 2 ohms is connected, what is the current they are asking, okay? So this is the condition, okay? So but they have mentioned one thing, it is a linear network, okay? So that means whenever voltage source value increasing, then automatically, so we can get similar in the similar ratio only, so output also will be changed, okay? See here 10 volts connected, so here also if 10 volts we have connected, how much is the current flow? See voltage source value I have doubled, so automatically here, so here how much? 1.25 into 2, okay? So it will be 2.5 amperes will flow, okay? See whenever this is and this one, okay? So same circuit only, okay? This is in first condition, this is in second condition, 10 volt only connected, 10 volt only connected, but here no resistance is there, here some resistance is there. That means this entire part, okay? So entire part we can just modify like, okay? Whenever there is no other resistance, 4 amperes is flowing. Whenever there is some resistance of 1 ohm, 2.5 amperes is flowing, okay? We can give like this. This entire two port network we can represent as Thevenin's voltage in series with the Thevenin's resistance, okay? So between these two terminals, okay? So between these two terminals, and now if I am short circuiting this, 4 amperes is going, okay? So this we can understand, but this VTH is nothing but voltage between these two terminals, okay? So between these two you have to check, okay? So you got 4 VTH voltage, not this is not a 10 volt, okay? Similarly, so the same circuit we can represent like this, okay? So if this is VTH, same, okay? Same conditions, right? So that's why VTH we can give, and this will be RTH, okay? So if you have connect 1 ohm, okay, what is the current here? 2 amperes, okay? But see why we have given it as a 10 volt instead of 5 volt? See whenever you are comparing two networks, okay? So it should have similar conditions, okay? So then only VTH in both the cases it is same only, okay? So if here 5 volt, here 10 volt is there, so here one VTH you will get, here different VTH you will get, okay? So if both are supplied with the same source, so then we can understand, okay? So okay, so in both the cases you will get same VTH only, so you can get the relation, okay? So VTH equals to 4 times of RTH, okay, in the first condition, okay? So here VTH equals to so total, okay? So RTH plus 1, okay? So RTH plus 1 into 2, okay? So into 2, like this we can give, okay? So anyhow VTH equals to 4 RTH. So in the we need VTH value and RTH value, then only this circuit we can represent, okay? Let's calculate VTH first, okay? So in place of RTH I will substitute VTH by 4, okay? So here let's substitute here, okay? So VTH equals to plus 1, okay? So in place of RTH I will give VTH divided by 4, okay? So VTH divided by 4 plus 1 into 2, okay? So then you will get VTH equals to VTH divided by 2 plus 2, okay? So then VTH by 2 equals to, so you will get 2, so VTH equals to 4 volt, okay? Similarly, when VTH equals to 4 volt, then RTH equals to 1 ohm you will get. Okay, so RTH equals to 1 ohm from this. Okay, what is the relation you got? VTH equals to 4 times of 1, then you will get 4. Okay, so that's why we have given like this. Now this entire circuit, okay, so entire circuit we can transform. Okay, so we can transform as similar to that network. Okay, so but same conditions it has to satisfy. Okay, same conditions you have to satisfy when same two port network is connected. Okay, so how it is, this entire network we have to change like this. Okay, so how we have to change? Okay, so the same VTH network is there, same VTH network, so which is nothing but 4 volt in series with the resistance 1 ohm. Okay, so connected like this, and in the load, okay, so what is the resistance? 2 ohms resistance is connected. Okay, so 2 ohms resistance is connected. Okay, so now what is the current? If you check the current, you will get 4/3. That will be wrong. Okay, so 4/3. Okay, so this will be the current 4/3 amperes. Why it is wrong? See here, 3 volt is connected. Okay, so now this also we have to change as 10 volt. Understanding, right? Okay, so this also we have to change as 10 volt. Otherwise, okay, otherwise for this condition, okay, so we need to convert the network. Okay, so let's try. We need to convert 3 volt also in terms of 10. Okay, so just like I will multiply this with 10 divided by 3. Okay, so then you will get 10 volt. So output side also you can multiply with 10 divided by 3. Okay, so now this network we can change as directly. Okay, so this kind of network, but current whatever value you are getting, this current is nothing but, okay, so 10/3 into I. Okay, so whatever calculated here, okay, so 10/3 into I equals to this one. Okay, so that means I equals to, so 3 will be cancelled, 4/10, so that will be the answer for us. Okay, so this will be the correct answer. Okay, okay, so let's solve the next question. Okay, so the Z parameter of the two port network are Z11 equals to 40 ohms, Z22 equals to 30 ohms, Z12 equals to, Z21 equals to 20 ohms. Okay, so then A comma B parameters of the same two port network respectively are. Okay, so same two port network they are asking, so they have given Z parameters, so all the 4 they have given. Okay, so let's take this as, so Z11 equals to 40, so Z12 equals to 20, this is also 20. Okay, so this is nothing but 30. Okay, so these are the Z parameters. Okay, they are asking about A comma B parameter. Okay, so no need of any formula. Okay, so without any formula, so you have to solve this one. Okay, so without any formula you have to solve this. Okay, how to solve? So I told already, whenever some parameters you are converting into some other parameter, available equations you have to take. Okay, what are the available equations? So V1 equals to 40 I1, so plus, okay, so 20 I2. Okay, so next V2 equals to 20 I1 plus 30 I2. Okay, so like this, what are the equations you need? So you want A and B parameters, means you need a A, B, C, D parameters or T parameters we need. Okay, so that means, so V1 equals to, so A, okay, so A V2, okay, so A V2 plus B I2. Okay, so here I1 equals to A C. Okay, so it will be C V2 plus di2. Okay, so generally these equations will be minus. Okay, so but we have to give it as a plus or minus, any one method we have to follow this one. Okay, so let's try. Okay, so what is the answer, what answer you will get for this one? Okay, so now these equations you need to modify in like this. Okay, let's check. You want the equation in terms of V1 V2 I2, V1 V2, okay, so not there, V1, okay, not there. Okay, second equation will compare I1 V2 I2. Okay, so where it is, I1 V2 I2. Okay, so I1 V2 I2. Okay, so if you modify this, you will directly get C and D values. Okay, so let's modify in terms of I1 you have to write. Okay, so I1 equals to, okay, so V2 1/20 Okay, so minus 30/20 into I2. Okay, so you got, that means C and D values you got. Now if you substitute in this one, directly A and B values you will get. Okay, substitute this here. So V1 equals to, so 40 into I1. Okay, so I1 is 1/20 V2, so minus 30/20 into I2. Okay, so this will be I2. Okay, so plus 20 I2. Okay, so total it will be, so V1 equals to, okay, so 40/20 is, so you will get 2V2. Okay, so 2V2. So next minus, already 0 0 will be cancelled. 40 into 3 is, so 120. Okay, so 120 divided by 2, otherwise 20 into 3. Okay, you can get 60 I2 plus 20 I2. Okay, so you can get this equation as V1 equals to 2V2, so minus 40 I2. Okay, so this will be second one. Okay, so but generally these equations here minus will be there, so that's why you got here minus answers. Okay, so answer for this is, okay, so directly, so we need this equation only, so this will be A and B will be 40. Okay, so A will be 2 and B will be 40. Okay, we have taken plus equations here. Okay, so anyhow answer for this question is 2 comma 40, that will be the answer. Okay, the next question. Okay, so next question is, the power consumed by a balanced 3-phase load is measured by 2 wattmeter method. The meter readings are 8 kilowatt and 4 kilowatt. The power factor of the load is, okay, so power factor they are asking. Okay, cos phi we need to calculate. Okay, whenever 2 wattmeter method we are using, phi equals to, so in measurements generally we will solve this. Okay, so tan inverse of root 3 into W1 minus W2 divided by W1 plus W2. Okay, so tan inverse of, okay, so tan inverse of root 3 into, okay, so in terms of watts or megawatts both are in the same only. Okay, so you will get 8 minus 4 is 4 divided by 8 plus 4 is 12. Okay, so 4 ones and 4 threes. Tan inverse of root 3 by 3. Okay, so that means 1 by root 3 you will get. Okay, so tan inverse of 1 by root 3 is, okay, so 1 by root 3, tan inverse of 1 by root 3 is, so what is this phi angle? It will be 30 degree. Okay, so 30 degree. So that means phi is 30 degree. What will be the cos phi? So cos phi will be the power factor. Okay, so power factor equals to, so you will get, so cos phi equals to cos 30. Okay, so cos 30 will be root 3 by 2. Okay, so cos 30 is root 3 by 2. Okay, so root 3 by 2 value is 1.732 divided by 2, that will be 0.866. Okay, so 0.866. so what will be the answer? 0, 0.5, between 0 and 0.5, so between 0.5 and unity. Okay, so this will be the correct answer. They should have give the exact value also. Okay, so that will be more good. Okay, so like this we could able to solve some questions. Okay, so anyhow, so we have solved near to, okay, so 15 to 20 questions we have solved. So anyhow, in next session, okay, so I will come up with some more questions. There are so many questions I have prepared and I have not prepared actually. So these are all previous Genco Transco questions only. I have just collected from our book. Okay, so anyhow, so if you need coaching, okay, so like for Genco Transco or GATE, railway examinations or ALP or junior engineer examinations, okay, just consider our institute. We are giving online classes, recorded classes, and similarly so offline classes also. Okay, so if you are interested or your friends also interested, just so give a call to our numbers. So we'll definitely give support in this one. Okay, so and we'll provide so at most. Okay, so we will give all the subject, and similarly so we will give the complete guidance for you. Okay, so anyhow, all the best. In other session, so we'll discuss about some more questions. Okay, thank you so much.